Hey everyone, it's Kyle, lead developer of CardanoSharp. And first off, I just want to say thank you for everyone who's supporting the project. It means a ton. We're working really hard. And today we actually get to show a little bit of what the library can do. So yeah, let's just jump in. All right, everybody. So let's explore the CardanoSharp library. I'm going to walk us through two sides of the library. So I'm demoing reading from the Cardano DB Sync database. So it's a Postgres database. I have things set up locally. I've synced up to the current epoch, but I don't have it currently running just for resource sake. But we will be looking at um, getting some transactions per epoch. So we're just kind of saying like, we've had this many transactions per epoch and, 131, which when we as of right now, 131 is the current epoch. Like I said, I'm not syncing at the moment, but I did sync up to the latest. And then after that, we're going to look at some blocks through the transaction hash. A lot of people, you're used to getting that transaction hash and looking it up. I will say that we're not going to show all the information. We're still working on this demo and building it out. But yeah, so let's just kind of dive in. We're going to first, it is on 131. It's all caught up to date, but we're going to start at 100. So let's just see how many transactions are in Epoch 100. So the database right now is showing 616. So just, all right, cool. So you can see Epoch 100 is showing 616 transactions. Ultimately, this is just a .NET web application using Blazor, and the user can put in 100. It takes that input, it runs it through the EF Core library in CardanoSharp, and accesses the database, does the transaction count, and pulls it back. We'll go ahead and do another one just to get some examples going. So Epoch 95 has 433. So 95. Hit that button. All right. So yep, 95, 433. Awesome. So that's a pretty simple example. The next one, we're just going to look at some transactions. Most likely they're just going to be of the same epoch here, but let's scroll down a little bit. Just grab a random one. I have the Cardano testnet block explorer just to make sure that we are showing the right information. So all right, we put in the hash. We got epoch 130, which, yep, it is 130 block. I'm just going to do a simple find on the page. Found it. Output for this transaction. All right, looking good. And the fee. Awesome. The time, yep, May 8th. Okay, this is technically the web page is showing like 2400, but it is in fact 12:34 p.m. So, all right, let's take another one. Just throw it in there. All right, cool. So again, Epoch 130. As I only did 5,000, so I'm sure there's a lot of activity going on. Block. Where are we at? Oh, you know what? It helps if I put the transaction in there. There we go. Yep, block is good. Total output. Looking good. And fee, yeah, that's looking pretty good, but just throw it in there anyway. Again, yep, time's looking good. May 7th, 10/12/05. Cool. All right, so ultimately, reading from the database, it just kind of makes it simpler for developers to, kind of build out stuff like this and, start reading the database, whether it's, a local database like this one, or maybe up in the cloud, or, in their own infrastructure see fit. Again, this is up on GitHub. Anybody can start using this, so, please do. Try to break it. Let us know where we can improve. It's greatly appreciated. I know it sounds weird. All right, so we're going to jump over to what I typically call the right side. So we have the read and the write. What we just did was reading from the chain. Now, in order to write to the chain, the first thing we need to establish is a wallet. So right now, we have creating and restoring wallets. And we're going to put together a little a wallet here, and what we're going to do is we're going to use IOHK's Cardano address binary to create a wallet essentially from command line. And what I'm going to do is we're going to see how it gets replicated through the .NET library. But yeah, so just, real quick, what I'll do is I'll just hit this button. It says generate new mnemonic, which is your words, right? So cool. All right, we got some words. Awesome. Now that's just kind of prove the point that we can generate mnemonics, click of a button, looking good. But we're not actually going to use that one. What we're going to do is we're going to generate one from the CLI binary here. Now I have put together some scripts just to make this much simpler. You know what? I'm even going to remove all from the demo folder here. So that's not the folder. Just to point out, nothing's in that folder. Sorry if this is really low level. As demoing something like this, it's kind of just part of the world you have to live in. So, but yeah, let's just get to it. So what I have here are a list of scripts, and the first one we're going to do is we're going to generate a mnemonic. Now, just to don't want people thinking I'm just writing the random stuff, but it's actually going to execute recovery phrase. That's your mnemonic. It's going to generate one, and it's going to do 24 words. And ultimately, we're going to give it a path where we want to save it. And we're going to get out of here eventually. Cool. So from here, I'm just going to execute that. And what we're going to do is we're going to put it in the demo folder. Cool. So let's see what our phrase is. All right. So we have this phrase. I'm just going to copy it. I'm going to throw it in here. Cool. So I've basically the library has went ahead and generated all the keys and a payment address that we can accept data. Now that's great, but let's prove that these keys are accurate, right? Like it's one thing to just show them on the screen and rely that they're working. So let's prove that they are working and generating correctly. So the first thing we want to do is get our root key. This basically drives every key and address that is in your wallet. So let's go ahead and get our root. One thing we will have to pass is the phrase, right? So the root is generated from the phrase. And let's give it a path where we want to save our root. Cool. All right, let's get what that root is. What I'm going to do is just copy it. I'm going to paste it on the screen. All right, so it found it. I don't know how else to prove that, so just a simple find on the page. It has found it character by character. All right, so the next thing we want to do is get our payment public key and our stake public key. Again, I'm just going to show what those look like. Let's see, generate public payment. Ultimately, it just takes in the root key, and then we get our child key. This is just a bunch of address pathing, and then which will give us our private key. And then you can see we're going to generate a public key, and we're going to output it to a directory. If you want to learn more about that, I definitely encourage people to dive into the library. It's very fun to get in here and create keys and kind of get your hands dirty with creating wallets. But let's go ahead and execute that. Public payment, cool. So the first thing it's going to take is the root key. So we want to give it the root. And we want to give it where we want to save it. So we're going to call it the payment pub. Cool. The next one is the stake. I'm going to go ahead and create both of these since they are needed for the final address. So again, let's just go ahead and look at it. So you can see here, ultimately the path is a little different, but ultimately we're getting the child private key, and then we're getting that public key, and we're going to spit it out to a directory or a file. So create the public staking key, and we want the root key because it's all derived from the root key. From here, we're going to call it the stake.pub. So all we're saying is it's the public.payment key, or sorry, the payment public key and the stake public key. All right, so now that we have both those keys generated, let's just go ahead and take a look at them and make sure that they are accurate from the CardanoSharp.net side. So demo payment, Awesome. So this is the public key. Just going to copy that. Simple. Find on page. Found it. All right, let's next do the stake. Awesome. Awesome. Okay, so we found that as well. The next one is a little more complicated in the sense that we have to chain a few more commands together. But ultimately, in order to create a payment address that you would give somebody to accept ADA that would automatically delegate your ADA, to your pool, you need your stake key to generate that as well. So that's why we generated the stake public key. But just to look at that, ultimately what we're saying here is this one's different. This is not the root key in this particular case. It is actually going to be the payment public key. We're going to generate a payment address, and we're just saying that it's going to be on the testnet. But that's basically the payment address. But we want what's known as a delegation address, which takes the stake key. And this is just an extra thing that no one really needs to worry about too much. But it just allows for that auto delegation when you accept data. So we're going to go ahead and create the payment address. Now remember, the first parameter is our payment public key. Then the second one is our demo stake key, or sorry, the public stake key. And then where we want to save our address, which we're going to call that base ADDR. Cool. So let's go ahead and look at what we generated here and make sure that it matches what we have on the .NET side. Awesome. Okay, so that's great, but what's really cool? If we can accept ADA from that. All right, so I was about to jump over to test Faucet, but since I had already used it within the past 24 hours, I can't actually get any ADA from it. But I do have a test net ADA account right here. And what we can do is just use the Daedalus wallet. So I'm going to go over here and I'm going to take the first address. Now, based on what we generated, this should match exactly what we have right there, and it does. Great. So what we're going to do is, just kind of demo that I can send ADA to it. I mean, ultimately, I guess the proof was already in the pudding if I was able to load it into Daedalus here and see the same wallet and everything. But yeah, so anyway, there we go. We were able to build a wallet, load it into Daedalus, and use it that way as well. But yeah, thank you for watching. All right, well, there we have it. So what we did there was we read from the chain and we created a wallet. More specifically, reading from the chain, there are two parts, and that was kind of the first part, using a .NET ORM called EF Core. And writing on the chain, well, all we did was create a wallet and accept data. The next part is going to be building that transaction, signing it so we can send it off to actually spend some of that ADA we got. I know that was really technical, and I appreciate you bearing with me, but with a project like this, that kind of comes with the territory. But anyway, until next time, I appreciate all the support, and thank you.